Okay, welcome back. Today is class number 18. A few different things today. First of all, quiz 2 is due right now at this moment. Throw it in the green folder right now at this moment. It is the only time I will take it. So hopefully it's done and in the green folder. If you do not have it done, you talk to me right after class, and you better have a very good story for why it is not done right now, okay? Coming up, project number 2 is due. This is Monday. This coming Monday, project 2 is due. Has anybody finished project 2 or made some good headway? Yeah, I mean, like several folks are there or almost there. You have all the tools that you need to do this entire thing. Don't wait around until Sunday night. It could make a stressful weekend for you. Try to do a little bit each evening if you can. Today we're covering section 2.6. It is all about combining functions, including the composition of functions. Kind of an important topic for us. And then coming up, just looking ahead, we can see 2 days on inverse functions, and then that's it for the test number 2. We've got a review day, and then we're taking our test October 28th. When is that? I guess a week from this Friday. Okay, so Wednesday next week. Wait, is that right? Monday? Yeah, week from Friday. Yeah, I think that's right. Questions on the calendar? Okay, so starting at the top of page 24, let's actually just go through the preview exercises together here. So in this case, we're asked to simplify this expression up here at the top. And so the first thing to do is to change both f of x's into this 3x minus 4, right? And this is just a substitution thing, and then we do some algebra to clean things up. One really easy thing to do when you square this is to say, oh, it's 9x squared plus 16, and then just leave it like that. And that's a real problem. Don't do that. No matter how tempting it looks, it's not right. So FOIL, write 2 of them, and you'll see this minus 24x. And then we combine terms, and I think we got 9x squared minus 30x plus 30. If you want, you could factor what number out of all 3 of those terms? Could factor out a 3 if you wanted to. Okay, domain, we've talked about this a few times this semester, so let's refresh our memory here. For domain of a function, when you're given a formula, like we have 2 formulas here, there's typically only 2 things that we're looking out for. You cannot divide by 0, and you cannot take the square root of a negative. Those are pretty much the 2 things we look for, the 2 standard domain type things for formulas. Okay, and lo and behold, one of them is a fraction, so we have to avoid dividing by 0, and the other one is a square root, and we have to avoid taking the square root of a negative. So let's write it down. All we care about is the bottom, so we completely ignore the top. It is irrelevant what's upstairs. We want to make sure the bottom is not equal to 0, so I guess technically we're trying to solve that, but we don't have a lot of experience solving not equations, so we're going to solve the equation, and then we're going to toss out whatever x values we get. Okay, it's a quadratic equation because of that squared. It's equal to 0. That's our standard form. You could do the quadratic formula, but if it factors, it's often quicker to do it that way. So what do we get here? Minus 3 and plus 1. Those sound good to me. And then now that it's factored, we can write 2 equations, either x minus 3 is 0 or x plus 1 is 0, and so we get x equals 3 and x equals negative 1. So that means that the domain, let's see if we can use more of our fancy notation. Remember this vertical line? It wasn't, it was such that, that's what the vertical line was. Set of all x such that x is, let's see, is x equals 3 good or bad? Bad. So x is not equal to 3, and x is not equal to negative 1. So that's our domain. Okay, for the other one, there's no division, so we don't have to worry about dividing by 0, but there is a square root, and we got to make sure we don't take the square root of a negative. It's kind of strange, actually, because earlier this semester we talked about square roots and negative numbers, no problem. What letter did we bring in on that day? I, right? Imaginary numbers. So square root of negative is fine as long as you are allowing imaginary numbers into the problem. But all the functions that we talk about are going to be functions of real numbers that output real numbers. And so that's why we go back to sort of pre-I days for us. Okay, we want to make sure that 3x plus 12 is not negative. Don't copy this little piece here, but I guess that's what we mean, right? Not less than 0. Yes? But we're not so great at solving not things here either, so can we make this an affirmative statement? Everyone agree that's the same? That not negative is equivalent to greater than or equal to 0. Yeah, and so that's what we'll solve. So this will be our standard way of finding domain for any square root function. You just take the stuff inside and make it bigger than or equal to 0 every time. Okay, so then we subtract the 12 and then divide by 3. So I think I get a -4 there. Yeah, but a little warning bell is going off in my head and hopefully in yours too. Multiplication and division for inequalities, we might need to change the direction of the inequality. In this case, we divided both sides by 3. Do we change the direction of the inequality or keep it? Yeah, you only change when you multiply or divide by a negative. So it's not any division, it's only division by a negative. So keep it. But it is a good moment to pause and ask yourself, does it stay or flip? Okay, so in this case, we're done. That's the domain. Set of all x such that x is greater than or equal to -4. Okay, so let's move on now to the demo. Today is all about creating new functions from old functions. So if you have two functions in your hands, you can combine them in a variety of ways, and that's what we're after in this lesson. Here's some notation. It's actually not going to be very meaningful until we get our hands dirty in the next example, but if you see these symbols right here, so parentheses around an f plus g, f and g are two separate functions, and then the second parentheses is the x, all that means is f of x plus g of x. That is just a shorthand way for writing add the two functions together. That's all. So notationally, it doesn't really contribute much. It's just a shorthand way of saying add two functions. Likewise, you can take two functions and subtract them. You can multiply them. You can divide them. There's a little extra warning here for division because when you bring division into the problem, you might potentially be dividing by 0 sometimes. And we know we can't divide by 0, so there's this little make sure that the bottom is not equal to 0. Okay. All right, so let's try some examples here. F of x equals x squared, and g of x equals 1 over x plus 1. We're going to find each of the following combined functions and their domains. Let's give this a shot. Okay, I'm going to skip the number line part and just jump into the table. F plus g, that says you take your two functions and you add them together. I'm actually going to add a little bit of symbols here. These are the brand new symbols we just saw on the previous page. F plus g of x, looks like times, but it's function notation, it's of, equals, and according to the definition, we just add the two functions separately. X squared plus 1 over x plus 1. That's it. You could combine them, right? We could make a single fraction with a common denominator. That's not what I'm about for this example. I just wanted to see, okay, we add two functions, no problem. I do want to think about the domain for this guy though. Domain. Does it have any square roots? Not squared, but square roots. No square roots, so no problems there. Does it have division? Yes, so potential problems there. You cannot divide by 0. What value of x? -1. So is x equals -1 in the domain or not in the domain? Not in the domain. Okay, so there's your domain. Everybody except for x equals -1. Okay, if you can add two functions, I guess we could probably subtract them too. It's exactly the same thing, just get the order right. X squared was the first function, that was f, minus 1 over x plus 1. Domain here. X not equal to -1. Same exact reasons as before. Okay, bottom left says FG. It looks very compact, but what's the operation we're talking about? That's multiplication. So we just multiply our two functions. X squared times 1 over x plus 1. Okay, now I know we didn't actually do any work to combine the two functions up above. That's just because I was lazy with the fractions and I didn't feel like making a lowest common denominator. But this one is so easy, we might as well just do it. As a single fraction, what do we get? X squared over x plus 1, right? Because we just multiply across. Okay, domain here. X not equal -1. Same. Nothing has changed. Still have that division by x plus 1, so we still can't divide by 0. I'm actually going to change, you have in your paper f over g. I'm going to flip that. Can you cross it off? I would rather do g over f. Okay, so I'll throw my parentheses here of x. Okay, big division. We just got to get them in the right spots. Which one goes on top? G is on top because of the change I made. So 1 over x plus 1 on top. And on the bottom, x squared. That's good. And be really careful with the length of that fraction line. It's your job to make clear because there's a fraction within a fraction. So you got to make it clear what we're talking about here because that is very different from this. All I've done is change the lengths of the fraction lines and they mean different things. So we got to make sure we write down the one that we mean. Yeah, so let's clean this guy up too. So I guess the way that I want to clean this up is to multiply, like I don't like this x, actually, I don't like this x plus 1 up here. So I'm going to multiply up here by x plus 1, which will just straight cross it off. But then I got to do the same thing down below. So upstairs, what do I have? Just plain 1. Downstairs, I'm just going to copy. It's an x squared times an x plus 1. That's it. Notice that we had to introduce parentheses there. Okay, domain here. Yeah. Right, because there was division, like extra division in this problem, there's actually another value of x that we have to exclude. X equals -1 for sure is still bad, but x squared is now living in a denominator. And what value of x is a problem here? Is 0, because 0 squared is still 0. And so x can't equal -1 again, but it also cannot equal 0. And so this is that extra piece where because there was division involved in the creation of this problem, you might be introducing more division by 0. So any division problem, you know, f over g, g over f, we have to just think about another possible divide by 0. Okay, so we did add, subtract, multiply, divide, and there's going to be one more way, a real important way, to take two functions and combine them and create a new one. So number 3, another way to combine functions is where we use the output from one function as the input for another function. For example, suppose that we define the functions m and f as follows. There's going to be a mother function. M of p is the biological mother of person p, and f of p is the biological father of person p, okay? All right, let's see if we can get our hands on this thing right here. M of f of p. The innermost input is which letter? P. That is some person. Then we work our way out from the inside. So what's the closest thing to that P inside? Is F. So that is referring to the father of P. Yes? The father of P is of their own person, right? It's just like a brand new person to start this problem from. And M is the thing that says the mother of whoever is in the parentheses. And so this final output is who? It's the paternal grandmother. It is the mother of the father of the person. The mother of the father of person. So, mother of father of P. And so if you're fancy, paternal grandmother. Yeah, that's right. Right, and so everybody had this person in their lives. The person may no longer be with us, but at some point, everybody had a mother of their father, and that's what this function is referencing. And so again, the key idea with composition is that the output for one function becomes the input for the next function. We took the output of the father function and put it into the mother function. Right? Okay. So here's the definition. Composition of the function f with g is denoted by, and then there's this thing here, which when I was a student, I read this as the word fog, like it looked like F-O-G, just those letters, the word fog. But really, it's just a brand new symbol that happens to look a little bit like the letter O, and it means put these two functions together where the output of the one is the input of the next. And so here is the way you will see it written. F circle g of x, and here is what it means. It means f of g of x. F of g of x. And the important thing is that you work from the inside out. That's the key, okay? So in this case, which function do you apply first, f or g? G, which is quite strange because in the English language, we read left to right. And the first letter I see, the first function I see is f, but that is not the first function we apply. Inside out, okay? Okay, let's move on to a specific example. All right, we've got our same two functions as before. So f is still the x squared function, g is still 1 over x plus 1. And we're going to evaluate f of g of 3, which is written in two different ways, but they both mean the same exact thing. So, as we said, we work which one first, f or g? G first. So here's what I'm going to do. Because we haven't done f yet, I'm just going to put f and then parentheses to remind me to do that later. But what we do now is the g. Okay, g of 3. Here's our formula. What is g of 3? 1 over 3 plus 1, which is 1/4. Yes? Right, so we did the g first, which is 1 over 3 plus 1, which is 1 over 4. And then, hey, f is just waiting, and f is the squaring function. So we just do 1/4 squared, which is 1/16. Okay? What's the difference between part A, which we just did, and part B? Reversing the roles. In part B, it's g of f of 3. Which one am I copying here first? What letter am I copying? We're copying g. We're starting on the inside, but we're copying the first thing. And then f of 3. What is f of 3? It is 9. And then we can do g of 9. No problem. What is it? 1 over 9 plus 1, which is 1 over 10. Okay, was f of g of 3 exactly the same final answer as g of f of 3? No, right? We got 1/16 and we got 1/10. So we're not fooling around. When we say the order matters, you get the wrong answer if you do it in the wrong order. And occasionally you might get lucky and it'll be the same number, but that's pretty rare. So we got to be sure that we're doing things in the right order. Did the order in which you composed the two functions matter? Yes, it did. Okay, let's take a look at part D. D and E are the trickiest questions of the day. I'm just going to rewrite our functions here so they're on the screen. X squared and 1 over x plus 1. Okay, here we go. Starting with f of g of x. Let's just write those symbols. Good practice with our brand new notation. F of g of x. Which symbol are we copying? F. So this is going to be f of something. Okay, up above we plugged a number in, like we plugged 3 into the g function. But here we're not plugging any number in. We just have g of x, which is itself a formula. What is the formula for g of x? It's 1 over x plus 1. So that is exactly what we are putting right in here. 1 over x plus 1. Okay, so here's the trickiest part for today, is that we are trying to apply f to something that is not a number. It is f of something complicated, f of 1 over x plus 1. So here's the formula for f. F takes whatever is in the parentheses and does what to it? Squares it. That is what f does. So whatever is in the parentheses, whether it's a number or a letter or those symbols, anything, f doesn't care. It's just going to square whatever is in the parentheses. So then this thing right here is 1 over x plus 1 as a whole thing squared. That's it. Let's try part E. G of f of x. Again, let's practice with the symbols. G of f of x, lots of parentheses. Yeah, we got to put them together in the right way. So which letter is getting copied here? G. Okay, so this is G of something. Okay, inside here is f of x. Inside here, we need to put f of x. What is f of x? Oops. It is x squared. So that thing right there is right in here. Everybody see it? Just replacing f of x with the formula, x squared. Okay, and again, here's the tricky part. We just have to think about what g does. G is a function which takes whatever is in the parentheses, makes this fraction with a 1 over, and then whatever is in the parentheses, it has only one role. It's to go right there. And then there's a 1 over, and there's a plus 1 at the end. But that's the formula for g, right? So you're going to have to kind of like, instead of focusing on the fact that this is a g of x, just see something even more abstract, like blur your eyes a little bit so you don't get lost in the details of what's there. But all you need to know is that whatever's there has to go right here. And there's a 1 over and there's a plus 1. So let's create the shell. I know that there's a 1 over and I know there's a plus 1. That is the shell for what g does to anything, right? What goes in that blank space? X squared. So whatever was in the g parentheses, this guy right here has to get copied over. Okay? That's the trickiest part. It's applying these functions to things that aren't just x. It could be anything we want in there. Aaron, you all right with that? Yeah. Okay, let's think about domains here. What is the domain of this 1 over x plus 1 squared? All right, so the domain again set of all x's except for -1. How about for this guy? Could x equal 0? Yeah, I mean, like 0 in the bottom is a problem, but putting a 0 in the bottom gives you a 1, right? Putting 0 for x makes a 1, and 1 is okay. So the question is, what values of x make it 0 here? This is what we're after, right? Solving that. Okay, I can do that. That's true. So what's the answer here? Right. Don't forget there is a plus or minus here. But what we said is that all the functions we talk about this semester have real numbers only as their inputs. So the fact that I is a problem is not a problem for us. So the question is, what real numbers for x are bad? And the answer is, there aren't any. So if there aren't any bad numbers, what's the domain? All real numbers. Or you could say minus infinity to infinity, okay? And I think Ivy was onto a different way to see that. Ivy, what did you say about x squared? Always. So Ivy says this is always positive, right, regardless. And then when you add 1, it is still positive. Could you make it equal 0? No, not if it's a positive something plus 1 is positive. So since there's no way to make it equal to 0, there's no bad numbers. The domain is all reals. And so this is quite strange for a lot of folks, is that, you know, like we're used to this x equals -1 being a bad number, but somehow when we compose these two functions in the second order, it disappeared. Why did it disappear? It disappeared because we didn't put x into the g function, we put x squared. And ended up with all real numbers for the domain. One small thing, it's going to be hard to sort of explain this with this example, but technically when we look at domain, the only thing that we looked at here was the final answer, right? But technically we also have to look at the previous answer. So we also should have looked at the domain here. What is the domain for 1 over x plus 1? It's still all the x's that aren't -1. So that's the right answer over there. What's the domain for this one? Yeah, there's no division here, right? X squared is all real numbers. Yeah, so all real numbers here and still all real numbers over there, and that's fine. But like I said, it's hard to explain with this example, but suppose that this thing right here had been a 1 over x minus 3 in the intermediate. Still, somehow it came around to 1 over x squared plus 1. If we just look at the final answer, it's all real numbers. But this 1 over x minus 3 was in there. It happened. It lived at some point in this problem. And what's the bad value for x? It's 3. And so even though the final formula had a domain of all real numbers, we would still need to exclude 3 because it came from something. At one point, it was 1 over x minus 3. Okay? I think you'll see examples of that in the activity. Pete? No, this example, right, it was all real numbers to start. So I was trying to like tweak the problem so that it would change the final answer. Like what the point of what I just said here is that you can't just look at the final answer when you're doing domain for composition. You also have to exclude anything from this intermediate step. For the x squared plus 1? Now, if you put -1, what do you get? Yeah, they're unrelated. Sorry about that. That's okay. Okay, I think that is good. All right, so on the next page is some class activities. Let's see how far we can get.